Hello, and welcome to The Complete History of Science. Series 2, Episode 1. Aristotle, the Philosopher as Scientist. I wanted to begin our second series by welcoming back everybody who listened to the first series of the podcast. Far more people listened than I'd expected, and I'm very grateful. However, if you're new to the podcast, then thank you for downloading, and I hope you join us on this journey through the history of science. In the first series, we started by exploring the question of where science began, taking a tour through arguably the first science, astronomy, before stopping at the point where it all began to stall during the Greco-Roman period. However, astronomy was far from the only science practiced in the ancient world. It is, in my opinion, a failing of too many popular histories of science that they start with astronomy before quickly jumping forward to the scientific revolution. This is unfortunate, as it leaves out many of the diverse, interesting, and ultimately important scientific ideas which were taking root in this period. When I called this podcast The Complete History of Science, I was serious, because my aim is to give a complete overview of the history of scientific ideas, at least until we reach the modern age. In the second series, then, we'll explore the other scientific fields which originated in the ancient world. This will often mean starting in the world of ancient Greece, because it was undoubtedly here where the foundations of science were being laid. The men responsible for this genesis, however, were primarily philosophers who, while not scientists in our sense, were developing scientific ideas which would become the basis for the scientific thought that followed. So today, it makes sense to start with the ancient philosopher who arguably had the greatest impact in the history of science, the man we know as Aristotle. Aristotle was born in the Greek region of Macedonia and worked in Athens around the 4th century BC. We know from the last series the central role that Aristotle played in the development of astronomy. However, his scientific work was much broader, and he contributed significantly to many scientific disciplines. Indeed, as we continue this series, there'll be few areas in which Aristotle's name won't be mentioned, and his ideas are the ground zero in many scientific fields. In the long term, most of Aristotle's ideas will be proved wrong. However, I still think that it's key that we cover him in detail, because he provides necessary context for later ideas. It's a mistake, in my opinion, not to take Aristotle's work seriously, or to relegate him to a footnote in the stories of, for example, Galileo and Newton. And that's because I don't think we can fully appreciate Galileo and Newton's scientific contributions unless we first understand Aristotle's. We'll find this repeatedly in many scientific fields, where it's in fact Aristotle's ideas which provide the background against which new ideas can take shape. In many areas, Aristotle was there first, and understanding his theories are key to understanding how so much of science originated and developed. Perhaps part of the reason that Aristotle is so readily dismissed is the sharp distinction we make in our minds between philosophy and science. However, this distinction wouldn't have been meaningful in the ancient world. While we nowadays think of philosophers as primarily interested in reason, metaphysics, or ethics, many of the earliest philosophers were actually interested in the workings of nature. This conception of philosophy as disinterested in the physical world was largely due to the work of another ancient philosopher. Plato was an older contemporary and some would say teacher of Aristotle, who worked alongside him in Athens. He wrote widely on many areas of philosophy. However, central to his work is a rejection of experience and observation as reliable methods for gaining knowledge. Plato believed that our senses and our perceptions were faulty, and hence give us an unreliable account of the world. While there may be some merit to this argument, Plato reached the extreme conclusion that this means we should completely reject observation as a means of acquiring knowledge, and instead solely rely on reason. As his student, it may be expected that Aristotle would have adopted this view. However, Aristotle was an extremely well-read and original thinker, and largely rejected this position in favour of a more nuanced one. Aristotle didn't dismiss reason as a tool, but argued that observation must be the starting point in any attempt to acquire knowledge. Part of the importance of Aristotle in the history of science, then, goes beyond any specific idea or theory, because his work would provide the intellectual heft which would defend observation as a solid basis for producing knowledge. Aristotle wasn't the first philosopher to defend this position, but was instead the last and perhaps the greatest in a line of philosophers known as the physiologoi. The earliest of these thinkers was Thales of Miletus, a philosopher born in the 6th century BC. His belief was that water was the primary substance of all matter, and he used this idea as a basis to explain various phenomena. A tradition of philosophers followed Thales. They had a diverse range of ideas, but were united in attempting to explain phenomena as being caused by materials. They meant this quite literally, so Thales believed that water was the main cause of all phenomena, whereas Heraclitus believed it was fire, and Anaximenes believed it was air. Of course, the ideas of these physiologoi now seem at best fanciful, and at worst incredibly retrograde. However, I don't think it's the details of these claims which have value. These thinkers were an important stepping stone in the development of science, because in contrast to most prehistoric cultures, they sought to explain phenomena in terms of natural causes. To illustrate the difference in this new philosophical thought, an interesting comparison can be made between Thales and the earlier writer Hesiod. In his poetry, Hesiod described the origin of earthquakes as the consequence of Zeus's wrath. Conversely, Thales' explanation of earthquakes was that they were the result of waves lashing the earth, which he believed was adrift on an immense body of water. The importance of the physiologoi instead lies in the fact that they attempted to give natural explanations of phenomena which were, by extension, open to criticism. This in turn meant that their ideas needed to be defended and were open to vigorous debate. Indeed, the ideas of these physiologoi are largely known to us through the critiques which Aristotle made of them. Aristotle's work builds on and fine-tunes the work of his predecessors, synthesizing their ideas into his larger philosophical system. While I think it's fair to dismiss the ideas of these early physiologoi, Aristotle's ideas are far more sophisticated and deserve attention because they were so important in the development of later science. As we've mentioned, the physiologoi were preoccupied with the idea that matter was fundamental in explaining physical phenomena. While Aristotle largely disagreed with the physiologoi on the details, he did give primacy to the idea that matter was central to explaining everyday phenomena, and this formed the basis of his most famous theory. Aristotle posited that there were four primary elements: earth, water, fire, and air. He considered all matter which we observe to be some combination or mixture of these four underlying substances. This theory wasn't fully original to Aristotle, but had been developed from the work of another earlier philosopher, Empedocles. Empedocles was, like Aristotle and the physiologoi, interested in the natural world. His major contribution in the history of science was to demonstrate that air is in fact a substance, rather than just empty space. In one of the earliest recorded scientific demonstrations, he used a device known as a clepsydra, or water clock. This is a vessel with two holes, one in the bottom and one in the top. By placing the bottom hole of the vessel under water, Empedocles observed that the vessel filled up. However, if he put his finger over the top hole, then water didn't enter at the bottom. Empedocles deduced that the air was preventing the water from entering, and hence must have some substantial form, like water or earth. Empedocles then suggested that these three elements, together with fire, make up all underlying physical matter. Aristotle refined Empedocles' theory of matter by suggesting that each element also has two corresponding properties, being either hot or cold, and wet or dry. So for example, fire was hot and dry, while water was wet and cold. However, these properties aren't immutable and can undergo change. For example, if you heat water, it goes from cold to hot, and hence becomes air. Aristotle, therefore, gives us one of the earliest attempts to explain a change of state. Aristotle's theory of matter wasn't unique in the ancient world, but was proposed in opposition to another school of philosophers, the atomists. Of these atomists, Democritus was arguably the most important. Democritus had argued that all matter was made of tiny particles, which he called atoms. He arrived at this theory through the observation that everyday matter was divisible. You can, for example, use a hammer to break a rock into smaller pieces. Keep hitting it, and the pieces will get smaller and smaller. He reasoned, however, that this was only possible up to a point, and eventually we would reach the smallest possible particles, which were the indivisible atoms. In Democritus's theory, atoms could differ in size, shape, order, and position, but otherwise they were the only really existing objects, and moved through an empty void or vacuum. This may seem a remarkably prescient theory, but it wouldn't be as influential as Aristotle's, at least in the short to medium term. Aristotle was firmly opposed to atomism, and spent a great deal of energy arguing against it. He was especially contemptuous of the idea of the void between atoms. Instead, he argued that space is full, and matter stretches continuously across all space, what is sometimes known as the plenum. Aristotle appealed to a combination of observation and deduction in order to argue this. For example, Aristotle observed that an object falling through a medium will have a speed which is dependent on the density of that medium. Specifically, the greater the density, the less speed an object falls with. He reasoned then that if an object moves through a void, it would move at an infinite speed, an obvious absurdity according to Aristotle, as it would imply the object would be in two places at once. Such arguments, of course, wouldn't withstand scrutiny today, but the success of Aristotle's theory compared to atomic theory was because at the time they gave at least a coherent explanation to questions which were being posed by the ancient Greeks. This argument also demonstrates how Aristotle's theories of matter formed a part of his much larger system, which Aristotle used to explain a great range of phenomena. So, for instance, Aristotle used his theory of matter to provide one of the first serious attempts to explain motion. Aristotle considered earth and water the heavier elements, and they were supposed to move directly downwards, while air and fire were the lighter elements, and hence naturally should move upwards. Aristotle of course realised that this couldn't possibly always be true, so differentiated between this natural motion of the elements and artificial motion, which only exists under coercion by an outside force. To give an example, a stone, which would be considered earth, should fall directly downwards. But if you throw it, you provide an external force which propels it forward. However, this explanation of motion left Aristotle with several questions to answer. Aristotle had implied a force was always required for an object to continue to move. And while this may appeal to our common sense notions of how forces work, if we scrutinise the idea slightly, we run into problems. Let's say you throw a stone. Why does it continue to move in the direction you throw it? After all, when it leaves your hand, you no longer provide any external force. However, Aristotle was ready with an answer. He suggests that after you throw the stone, there's still a force acting on it, provided by the surrounding air, which continues to propel the stone forward. This again makes some sense within Aristotle's larger system, because the ear is a continuous medium which acts upon the stone after it's left your hand. Aristotle expanded this idea to explain how objects move through resistive mediums. He hypothesized that the motion through a medium was determined by the density of that medium, coming to the sensible suggestion that an object moves more slowly through a denser medium, owing to a greater resistive force. It's worth noting, however, that Aristotle's theories weren't explicitly mathematical. As we know from our account of ancient astronomy, science at this time largely lacked any quantitative basis. Aristotle also lacked sophisticated notions such as speed or velocity, and discussed motion purely in terms of distances travelled and time taken. However, he did make arguments from which mathematical statements could be inferred. Most famously, Aristotle suggested that the speed which an object falls is directly proportional to its weight, and hence an object twice as heavy should fall to the ground twice as quickly. This idea would go on to have a perhaps surprisingly long history, given that it should have been immediately apparent, even in Aristotle's time, that it was wrong. Because again, while it may appeal to our common sense notions that heavier objects fall faster, the implication was that an object, say, 100 times heavier, would fall 100 times faster. This can be demonstrated to be false by even the most rudimentary experiment. However, this raises an important issue we should address, because despite Aristotle's appeal to empiricism and observation, he never conducted experiments. Instead, Aristotle believed it was important to observe the world without imposing any artificial constraints. The historian of science David Lindbergh presents Aristotle's line of thought, and the argument goes something like this. If we want to discover the nature of a thing, we should observe it in its natural, unobstructed state. If we instead pose constraints or observe an object in an artificial experiment, we corrupt the behaviour we hope to observe. This is, of course, antithetical to the scientific method which would develop in the 17th century. Eventually, when Aristotle's ideas would be unseated, his theories of motion would be one of the first battlegrounds, and one where experiment would ultimately lead to his ideas being rejected. However, Aristotle's observational approach still has much value, and this would be especially the case in the field to which he has the greatest claim to have personally invented, that is, zoology. While there had been interest in animals prior to Aristotle, he was the first person to take seriously the study of animals as an intellectual endeavour. This is reflected in the volume of extant work, because before Aristotle, there are only scattered references to animals in Greek philosophy. But in Aristotle, we have at least 3 major works dedicated to both the physiology and the behaviour of large swaths of the animal kingdom. Aristotle gathered masses of data to this end, and his writings contain descriptions of over 500 different animals. Aristotle must have made some of these observations personally, and he seems especially familiar with many species of fish. This is perhaps not surprising, given the proximity of Greece to the Mediterranean Sea. More unexpected, however, is the various descriptions he gave of exotic animals native to North Africa and Central Asia. Some of this information undoubtedly came from travellers and reports which Aristotle had gathered. Aristotle, however, is no Pliny the Elder, and should be commended for his scepticism, for not necessarily accepting all reports that came his way. He also clearly relies on his own observations to disprove some of the more wild claims made by his predecessors. The historian Herodotus, for example, had claimed that hyenas are hermaphrodites and self-reproduce. Aristotle, by contrast, demonstrates his commitment to observation and made careful examination of the hyena's genitals, demonstrating that though similar, the male and the female have their own reproductive organs. This is but one example where we can be fairly sure that Aristotle seems to have personally made the observations he reports. Incredibly, and somewhat inexplicably, Aristotle manages to include descriptions of exotic animals he couldn't have possibly obtained from travellers. For example, it's plausible he could have gathered from others that elephants have a large body, a trunk, and tusks. But how could he have possibly known they don't have a gallbladder, or that the elephant's liver is roughly 4 times the size of an ox? It's speculated that Aristotle must have dissected or witnessed the dissection of an elephant, though how this would have been feasible in ancient Greece is unknown. One speculative suggestion is that he may have had some unknown collaborator, possibly his nephew Callisthenes, who was part of Alexander the Great's expeditions into Africa and Asia and sent an elephant home to Greece. That Aristotle did carry out some dissections himself, though, is almost certain, because he made discoveries on the internal workings of animals. Most celebrated of these discoveries, he described the reproductive system of a dogfish, discovering that, somewhat similar to mammals, they give birth to their young alive, what we would know as ovoviviparous. This wasn't reconfirmed until the 19th century, when Johannes Müller performed a similar dissection. We should perhaps, however, be careful not to overstate Aristotle's scientific objectivity, because he was also liable to speculation and whimsy amongst his more celebrated successors. For example, Aristotle can't help but anthropomorphize his descriptions of some animal behaviours, so the ox is sluggish and good-tempered, the snake treacherous and mean, horses intelligent, and the fox crafty and mischievous. Likewise, his biggest and most influential mistake in zoology was in endorsing the idea of spontaneous generation. Unable to observe the mating behaviours and reproduction cycles of certain animals, Aristotle suggested that these animals were instead generated spontaneously from non-living matter. So, for example, snails supposedly grew spontaneously in muddy ground, whereas scallops and clams would develop from sand. This theory would again have a very long history, and wouldn't be disproved until Louis Pasteur demonstrated the converse in the 19th century. Nevertheless, Aristotle also made one huge positive contribution to the broader development of biology, because he created the first system of classification for living things. His system is based on a nested hierarchy, and bears more than a passing resemblance to what we would recognise from Linnaean systems. Aristotle separated animals into 2 major classes, blooded and bloodless. Within the class of blooded animals, he included mammals, birds, and fish. He then further divided these subclasses into various species or genera. Aristotle's system was based on observations of similarities of traits between these animals, but he also recognised it was difficult to make classifications of some species within this system. Overall, he takes a largely pragmatic approach to the problem, and frequently settles upon what is mostly true. This problem of how to group animals within classifications would endure, and not finally be resolved until it was eventually settled in modern classification systems based on genetics. While this early system is largely forgotten, I think it is amongst Aristotle's greatest achievements, and there is no better compliment than that paid to it by Charles Darwin, who famously remarked that Cuvier and Linnaeus were mere schoolboys next to old Aristotle. So, for today, we'll leave Aristotle here. However, as I hinted at the beginning of the episode, we'll not really be leaving Aristotle. He'll rear his head repeatedly, again and again throughout this series, and long into the future, in virtually every field of science we dare to cover. Nevertheless, Next time, we'll return with an episode on another of the great scientific figures of antiquity, Archimedes.